Hi everybody, welcome to the ecological model of correspondences between color and sound. It has been known for long that there's a tendency to associate colors with pitch. For example, many people would think that yellow somehow matches a higher pitch, let's say beep, than blue, let's say moop. Several approaches have been proposed to explain the origin of cross-modal correspondences. These include structural properties of the brain, conventions in language, the pleasure produced by different sensations, and our experience with the environment. Here, we test the idea that cross-modal correspondences have an ecological origin. According to this idea, color and sound are both related to meaningful objects and phenomena in the environment. Our approach is inspired by Palmer and Schloss' ecological model of color preference. The key idea here is that people like colors that are associated with objects and materials they encounter in their environment. For example, many people very much like blue because it is associated with the sea and the sky, and most people like the sea and the sky. Analogously, we investigated whether associations with objects in the environment could predict color-sound associations. For example, people might associate blue with a low pitch because they associate the sea and the sky with both a blue color and a low pitch. To test this model, we first measured color-pitch associations. Second, we measured associations between colors and objects in the environment. And third, associations between those objects and pitch. If the ecological model holds, the second and third measurements should predict the pattern of the first measurements. We measured color-sound associations with these 24 colors on the left, and observers adjusted the pitch across 20 approximately equal steps between 200 and 2300 Hz. To measure color-pitch associations, colors were shown one by one, like down on the left here, and observers adjusted the pitch that matched the color best in their opinion. This provided us with a very systematic pattern of color-pitch associations on the right here. The y-axis shows the adjusted pitch level, and colors are ordered by that pitch level along the x-axis. Especially dark desaturated colors tended to be associated with lower pitch and vice versa. For the measurement of color-object associations, we would first identify candidate objects that observers associate with each color. We would present a color and ask observers to produce the first 3 associations with that color that come to their mind. We would then take the 3 most frequently named concepts for each color and ask participants to rate how strongly that concept matches the color. The average matches indicate the association strength between objects and colors. For example, in the diagram on the bottom right here, we can see that blue was strongly associated with the sea, water, and the sky, but not with warmth, aubergine, and flowers, which are more strongly associated with other colors. Finally, we presented those concepts as written words, like in the bottom left here, and asked participants to adjust the pitch that best matched each word. Results on the right show that objects were associated with very different levels of pitch. Pitch level is shown along the y-axis and objects ordered by pitch along the x-axis. For example, the sea was associated with low pitch, while the sky and the sun tended to be associated with higher pitch. We then calculated a model that integrates object associations to predict color-pitch correspondences. The formula looks rather grim, but it's actually not that bad. The key part that integrates object associations is the red term on the right here. This is the average pitch association for all the objects associated with a given color, and each object pitch association is weighted by the strength of the object color association. The ground average in green here is just a point of reference around which the predicted values vary. And the blue term here takes into account how specific the object color associations are. When colors are associated with a few specific objects, the term is high. For colors that are associated with a large range of different objects, the term is low, reducing the importance of the color object associations. And here are the main results. The red line shows the color pitch associations predicted by the model, and the black line are the measurements. Apart from white, the measurements are very close to the model predictions. Not surprisingly, predicted and measured values are highly correlated, explaining 72% of the variance. Now, you might have seen that not all concepts participants associated with the colors were objects or materials. In fact, some participants spontaneously produced color-related concepts, such as dark, bright, or garish, instead of objects. For some colors, they also produced abstract concepts such as calm, death, or danger. These abstract concepts show that not all colors are primarily related to concrete objects and materials. However, if we remove color-related and abstract concepts from our model, the model still predicts more than half of the variance of color-sound associations. In addition, our results were primarily driven by lightness and to a lesser extent by chroma. For this reason, we do not yet know how well the model does in predicting associations with hue. In sum, our ecological model has proven to be successful. It is not clear why those objects and phenomena are related to pure tones, since none of them makes those artificial sounds. However, there might not be a simple causal relationship. Instead, color and sound might be part of a broader mental network. That network might link different features across modalities according to more complex patterns experienced when interacting with the environment. And these patterns may define fuzzy supramodal categories, which in turn allow us to identify meaningful objects and phenomena. That's it. Thanks for watching.